Hi everyone, welcome to Adarsh Model Train. So today we will see how we can configure a Snap Turnout with the help of Relay Switch using REST API. So let's get started. First we'll go to our GitHub page which is github.com/adarsh-model-trains. Once we go into that, we'll just go to repositories. In the repository we can see Jmri Mqtt Spring Transformer wireless ecosystem. It's a private one, but I'm making it public very soon. Once we get into this, we can go into ESP solutions here. We have already covered ESP and Arduino solutions, but now we are taking up ESP solutions. So we'll go into ESP solutions here. And here we can see we have Esp8266 REST-snap turnout signals. So once we get into that, we can download the source code here. We'll just download on the desktop. We'll just extract the code. Just open the code into any other editor which you like. And here what we have to do is we have to just go into config. Here we have to change the turnout board to 1 because we need only one turnout today. And light boards, we are not configuring any lights, so light board will be 0, total number of board will be 1. Wireless Wi-Fi information you can change based on your requirement, and this is the IP address for the server where our Spring Transformer is executing in the port. This is the API URL. And light, we are not doing anything, so let's keep it, but normally should be true. That's it. So what we will do, we'll just I have ESP8266. Let's connect to MacBook and then test it. Upload the code. I've connected it. Let's check the port, and so port is okay. Board type ESP82 node MCU. Yeah, everything is good. Let's upload the code. So first it will compile the sketch and it will upload the sketch. So usually it will take time in ESP as compared to Uno or Mega. So now its code is compiled and it's uploading the code. Now code is uploaded. Let's open the serial monitor. So here you can see connected to Wi-Fi but not able to connect to server. See here, error, server not reachable, because we have not started the server. That's fine as of now. Let's close this. And first thing what we will do, we'll start the MQTT in Spring Transformer application. So let's go to desktop. cd mqtt config. So we have started the transformer application here. Sorry, MQTT, and let's open the another tab here. Go a little bit back. Go to Spring MQTT here. Let's see. So we'll just, here we can see this is a jar file. We have a jar file, and this is a property file and configuration YAML file. Let's open the configuration and let's validate what we need. So once we go into that, if for more detail, just see the previous videos because I have explained each and every properties in detail. So for nodes, we'll go to node 1. For node 1, node is enabled, publishing is enabled. So we'll just make sure REST API is enabled because we are we want to test it to REST API, we can just make it false, this one, if we want. If you are only using REST API, then you can make it false, so it will not publish data to MQTT topics. Here you can see the cache size, count, light count is 0, 2 LED signal count, 3 LED signal count is 0, servo turnout count is 1, snap turnout count is 1, total number of count light board we need only. Total number of turnout board we need 1, light board count is 0 because we don't need light, we are not testing today lights. So to start the application, what we can do, we can just go to GitHub page, go to the main project, and here we can see we went into this ESP solutions. Here below that we can see the Spring Jmri MQTT transformer. Once we get into that, we can download the jar file, we can download the configuration files here, and each and every detail is mentioned on this readme page. You can just go through that, just copy paste this command and paste the command because we already have done the changes in the configuration file. So application will be started, and if we go down in this page, we can see here is a REST endpoint to see the description of the configuration for the nodes. So once we hit it, we can see here it will give you all the nodes configured on the system, but I am more interested into node 1 only, so I'll say slash node 1. There's another API which is just below this here, description node and node identifier. It's a node ID, and here you can see node ID 1 enabled, it's enabled, publishing is enabled, REST API is enabled, light count is 0, 2 LED count is 0, 3 LED signal count is 0, and servo turnout count is 0, snap turnout count is 1, turnout board required is 1, light board count required is 0. It's publishing data on this topic. Here it will say total number of light pin 0, signal pin, 2 LED signal pin is 0, 3 LED signal pin is 0, servo turnout pin is 0, and here you can see snap turnout pin. We require 2 pins on the PC9685 board, and total number of board required, it will tell total number servo turnout count board required is 0, total number snap turnout count required board is 1, total number of light and turnout board is 0, and after that it will tell you how we have to configure it in Jmri address. So Jmri address 50001, board number, pin number, status. So board number 0, pin number 0, it will send a throw signal. Board number 0, pin number 1, it will send a close signal. So that's the reason we need 2 pins here, 0 and 1. So let's do one thing, let's see how we can configure the boards. Here so now here if you see in the same page from where we have downloaded the code, I have mentioned how we have to configure it. So from pin number D1 it will go to SCL pin of the PC9685 board, and from D2 it will go to SDA pin. So what you can do, if you can just take the 5-volt power supply and pass it to the side of the PC9685 board, and you can pass the SDA SCL line from the Esp8266 to PC9685 board, and you can pass the power supply, or you can use the alternate power supply. So here I have configured everything. I'll show you how I have configured it. So here you can see this is a this is a node MCU. From node MCU you can see SC from D1 and D2, SCL and SDA pin is going to the PC96 board here, and here you can see this is an external 5-volt power supply which is coming to this breadboard. So I have set up the common ground here. So from the ground side, from negative side, I have passing it to ground side of the G pin of the node MCU. And here you can see on the side, this loose connection. Okay. So here you can see this blue one is a GND and white one is a 5-volt power supply going to PC9685 board. And here you can see this red and brown is carrying 5-volt and GND to the PC9685 board here. And here this brown and red and brown, it's taking 5 volt power supply to the two relay switches here, and this green and blue is taking input signal for controlling these two relay switches. Now let's come to this side. Here we can see this is an external 12 volt power supply which is coming from adapter here. It's going to this breadboard. So from this plus 12 volt positive side, I have taken it to the common, which is a middle pin in both the relay switches. And here you can see from both the sides. Here you can see there is a gray and white is going here. So gray is taking power for the blue and white is taking for the red. Here black and white, it is taking power from this relay switch, and black is powering up the blue one and white is powering up the red one. So here once you connect everything, and then you can see the side where LED is continuously glowing. You should never put your turnout towards that side. The reason I'll tell you, because what will happen, it every snap turnout it need a power just for the few millisecond, and after that it will, if continuously if you are powering up, it will burn out immediately. Just to save it, you should always test it like this first, and based on that testing you will identify which side you have to configure. So here you can see black side, so black is this side here, and here you can see gray is this side in the relay switch, this one, and black is this side. So you know that now where you have to connect the open and close wires of the relay switch. So let's do one thing, let's test it first. So let's open the Panel Pro. So Panel Pro is open, but before that let's make sure that we are on the right network. We are on the right network now, and let's go to Tool Table Turnouts. Here, so we have already seen like address number 50,001 we have to configure. So we already configured the 50,001 here, and what we can do is we'll just open the serial monitor here. So now again it's saying server not reachable. Let's clean it and press the refresh button here. So now connected to Wi-Fi, and it's able to connect it to the server. So now we'll do the testing. So here you can see, once I'll just, so you can see the light will go from here to blue will be on for millisecond, and it will go back. And if I just say close, so here it will go here and it will switch off. So blue will be open for a second and then it will be closed. So if I just show you more closer here, so that's the reason I'm telling you to always configure the turnout on the blue side. So let's do one thing, let's configure the turnout and then test it with the final configuration. So now if you see here, I have configured everything. So what I did is, here you can see this red wire, this is a common one which is going to the middle in the snap turnout, and this green and this is green and black I guess, which is coming from the blue one. Always configure it before the register here, before the register. And here is a yellow and blue which is towards this blue side, configured before the register. Okay, because if you configure after the register, it will take all the energy, it will take all the power and your turnout will not work. Always configure it before the register if you are doing in this way. Once you identify it, you don't need lights and all, it's very pretty simple. So let's do one thing, let's test it. So let's throw it. So for throw, I guess this will work. Here is thrown is done, and if I'll just close it this side, here you can see. So I'll just show you in more closer view. So here is a throw one, and here you can see. So actually what I did, if you see the turnout position is wrong, you just swap this one to here, this one to here, and it will work accordingly through. And I just, for the demo purpose, I kept it like that. So if you see here, so light will go for a few seconds there and come back, and now for close it will come this side. And the thing which I have not mentioned it, this from Pca9685 board, from pin number 0 and 1, it's taking to the input pin of this two relay switches. That's the reason we have seen here. It required two pin number 0 and pin number 1 from Pca96 board, and that's what we have configured here. If you see here, pin number 0 and pin number 1 we have to use. So we have used pin number 0 and pin number 1 from this Pca9685 board for controlling these two relay switches. We can configure n number of relay switches here based on availability on the pins on the port. So we can so how we have configured, how we can generate all this address. There's a separate video, specifically separate video which I have posted long back. You can check into the channel and you can see how we can generate the addresses for this Pca9685 board. We can configure 64 board together, and in 64 boards we can have 1080 pins. So we can use that many pins with the one node, one Esp8266, and that many things we can configure in our node. So I guess that's it. If you like this, please subscribe to my channel and share your thoughts and comment and share with your friends, and stay tuned for upcoming content. Thank you.